we are from Group 8. For our group project, we choose Coulomb's law, which is to investigate the effect of charge on electric repulsion. Our group members are Nurul Ain binti Zahari, Nur Shazwin binti Ramli, Nur Faiza binti Hambali, Muhammad Aiman bin Muhammad Razi, and also me, Aliazia Shakira binti Zailani. The objective of our experiment is to observe how the strength of electric repulsion between two charged objects changes with the magnitude of charge based on Coulomb's law. How we conduct this experiment is to observe the behavior of charged and uncharged balloons with each other and tiny pieces of paper to verify Coulomb's law by noting any changes in the repulsion between them.
Next, I will be talking about the concept of Coulomb's law. Coulomb's law is a fundamental principle in physics that describes the electrostatic interaction between charged particles. It quantifies the force between two charged objects based on their charges and the distance between them. This repulsion occurs because like charges positive repel each other according to Coulomb's law. The experiments demonstrate the fundamental principle that charges of the same sign repel each other, while charges on opposite signs attract each other.
Next is theoretical background for Coulomb's law. The magnitude of the electric force that a particle exerts on another is directly proportional to the product of the charge and inversely proportional to the square of the distance between them. Mathematically, the magnitude of this electrostatic force F acting on two charged particles Q1 and Q2 is expressed as F equal to KQ1 Q2 over R square.
To conduct the experiment, you will need two rubber balloons. Inflate them to a suitable size and tie one end of each balloon securely with a string. This will provide tension and allow the balloons to hang freely. Next, gather small pieces of paper to visualize the electric field line. This paper will be affected by the charged balloons. To charge the balloons, rub them with a fur cloth to create an imbalance of electrons. However, it is important to take safety precautions. Handle the inflated balloon carefully to prevent bursting. Avoid charging the balloons to a very high voltage as it may result in small electric shocks. Once prepared, observe how the charged balloons repel each other and use the scattered pieces of paper to visualize the electric field lines. Remember to prioritize safety while conducting the experiment, ensuring proper handling and avoid excessive charge build-up.
Next, I'm going to explain to you guys how this experiment works. Firstly, you have to rub the balloons against a material that easily generates static electricity such as towel or your hair. After rubbing, the balloon becomes negatively charged while the material you rub against may acquire a positive charge. Now, bring the charged balloon close to the small piece of paper without touching it. You will notice that the paper is attracted to the balloon and may even stick to it for a brief moment before falling off. This effect occurs due to the electric repulsion between the light charges. When the balloon is negatively charged, it induces a positive charge on the side of the paper facing it. The positive charges on the paper are attracted to the negative charge on the balloon, causing the paper to move towards it. However, as soon as the paper comes close to the balloon, it acquires a negative charge by induction. Since both the balloon and the paper are negatively charged, they repel each other, leading to the paper detaching and falling off the balloon. This phenomenon demonstrates the effect of charge on electric repulsion. The light charges repel each other, causing the paper to be repelled by the negatively charged balloon. From this equation, it is evident that the charges of the objects directly influence the magnitude of the electric force between them. The higher the magnitude of the charges, the stronger the repulsion or attraction between the objects. When both charges have the same sign, they repel each other due to the light charges. This repulsion arises from the exchange of virtual particles known as photons, which mediate the electromagnetic force. The repulsive force increases as the charges on the objects increase. On the other hand, when the charges have opposite signs, they attract each other. The attractive force rises because the opposite charge create an imbalance in the distribution of electric charge.